So both total derivative and partial derivative of functions can be computed in MATLAB using the MATLAB Symbolic toolbox. So let us go to MATLAB and see an example, and we'll start with the simpler derivative, which is the partial derivative. So this is my first example, and I have a function z which is defined as x squared y plus sin xy. So px here is used for finding the partial derivative of z with respect to x, and we find both total derivative and partial derivatives with the aid of the diff function. So for the partial derivative, I give it two arguments. The first argument is the function I want to differentiate, and the second argument is the independent variable I'm considering. So since I'm considering the partial derivative with respect to x, my independent variable would be x, and y will be kept as constant. So here py, I use it to compute the partial derivative of z with respect to y. Therefore, y will be my independent variable and x will be kept as constant. So the subsequent code is how I tend to display my solution for px and py. So clicking on run, you can see in the command window I have my partial derivative with respect to x, which is computed as 2xy plus y cos xy, and the partial derivative with respect to y is just x cos xy plus x squared. So you can try any function that you like. So for example, if I want cos xy, for example, here I want times maybe tan y. If I run again, so here is my solution. So moving to the total derivative example, I have my function, which is the same function that I earlier on considered for the partial derivative, that is equal to x squared y plus sin xy. But the only difference with the partial derivative is I have y defined as x squared. That means y and x are interdependent, and in that case I'm dealing with a total derivative problem, and I need to use my chain rule formula, which is here. The x will be delta z delta x plus delta z delta y times dy dx. So I need to find these three terms. So in order to find delta z delta x, I need to use the diff function again, and then I use my z as the function, and the independent variable will be x, and my delta z delta y will have an independent variable of y, and here dy dx is just the total derivative of y with respect to x. So the function here will be y and the independent variable will be x, and then substituting them into the formula, I will be able to obtain my total derivative of z with respect to x, which is printed in the code below. So clicking on run, I will have my total derivative with respect to x. If you want to learn how to solve definite and indefinite integral in MATLAB, watch the video on the screen. Thank you for watching.